Hello everyone, welcome to our channel. Today we are treating indices. So what is indices? Indices, like we know, is a plural word for the word index. Yeah, the plural word for the word index. It can also be referred to as the power or exponent. So in some books, when you come across powers or exponents, it's still talking about indices. So indices is the basic operation of numbers with their powers. That is to say, the study of numbers and powers. For example, when you have the number as a and it's raised to power n, what is it saying to us? It's telling us to write a times a times a times a raised to power n. So what we have here is we have a base, which is the a, and the n, which is the power, is telling us the number of times the base should multiply itself. As further example, we have 2 raised to power 2. It's simply telling us to multiply 2 times, which gives us 2 raised to power 2, which is 4. And what we have 2 raised to power 3, it becomes 2 multiplied 2 3 times. 2 raised to power 3, 2 times 2, 4 times 2, 8. And it gives us 8. So what we have here, we are having a base number and it's raised to a power 3. So like I said before, the power is telling us the number of times this base 2 has to multiply itself. So since it's raised to power 3, the base number 2 needs to multiply itself 3 times. And the final answer we got is 8. So that brings us to the laws. In doing this, there are laws that must be followed. And number 1 law says, in no particular order, if a base number s is raised to power n, and the same base number s is raised to power m, 2 different powers raised by the same base number, the law says you write the base number once and add their powers. This becomes of it. So you are writing the base number once and you add the respective powers. That is the first law. For example, if we have 2 raised to power 3 multiplying 2 raised to power 2. So what did he say we should do? Write 2 once, add the powers. 3 plus 2, 3 plus 2, which is equals to 2 raised to power 5. You see? And to prove it, you say 2 times 2 times 2 in 3 places, 2 times 2 times 2 in 2 places. So if you do this, you have 2. How many times? 1, 2, 3, 4, 5. 2 raised to power 5. Remember, they are all raised to power 1. Eventually, we have the same answer when we did our addition. So this second one says, when we have the same base number and the operation is division, we are to write the base number once and subtract that power. It becomes n minus 2. This is the case when you have the operation is division. Unlike your previous one, the operation was multiplication. When it's multiplying, you add their powers, and when it's dividing, you subtract their powers. So if you want to go by example, like 2 raised to power 3 divided by 2 raised to power 2, it becomes 2 times 2 times 2, 3 times divided by 2 times 2. So what do? This cancels out, this cancels out. It becomes eventually as 2 raised to power 1. You see that? So from here, this is the same thing as 3 minus 2 is 2 raised to power 1. The same answer. So this one holds. And the third one goes by, if you have a base number x and it's raised to a power inside the bracket and we have another power raised outside, what you simply do is to write the base number once and multiply their power. It's still the same thing as multiplication. N raised to power n times n. And the fourth one is saying that anything raised to power 0, the base number is raised to power 0. Obviously, anything raised to power 0 is 1. Anything raised to power 0 is 1. And number 5 is saying that when the base number is raised to a negative power, When it's raised to a negative power, you introduce a reciprocal. That is to say, you say 1 all over s raised to power n. The negative sign has disappeared because of the introduction of the reciprocal. You must be watchful of that. And this, we are having a base number s raised to power m all over n. So this becomes the square root of s. This is very essential. You see that the denominator is what you use to form the square root, and the numerator becomes their entire power. The denominator forms the square root, and the numerator is not the only power that exists. Okay, so when we have two bases raised to the same power, n and n, what you do is to write the base and raise them to one power. It's still the same. We don't have time to prove this, but they are fine. S and y are raised to the same power. So what you do is to multiply the x and y, the different base, and raise them to that singular power, the common power. The eighth one says when you divide the base over the second base and they are raised to the same power n and n, it's okay if you write s all over y raised to power n. It's very fine. You see this? But there is another one that says when you have a raised to power m equal to a raised to power 2, for example, m and 2 are the powers respectively. You see that we are having the same base, the bases are equal, but the power are different. Since the bases are equal, the laws of indices permit us to say m is equal to 2. So you equate the powers when the bases are equal. You see this? So with the help of the law, we can successfully dive into solving question relating to exponents and maybe other mathematical expression or equation. So we want to take an example to see how we apply the laws that we have learned. And we're having 1 over 3 raised to power s equals to 27 raised to power s minus 4 to be evaluated. So we want to apply the knowledge of the law in solving this. So first of all, we want to transform 1 all over 3 to a form that is usable. For example, if you see this, similar to what we have here, you see, so we want to make it this form. It becomes 3 raised to power minus 1 raised to power s equals to, and 27, if we have 3 times 3 times 3, 3 times 3, that is 9, and 9 times 3 is 27. So if you want to write the 27 in an index form, it becomes 3 raised to power 3, a base and a power. So 3 is the base and 3 is the power, and it's multiplying x minus 4. You see, so we are going gradually. And if you remember this, when you have the power rule, the power multiplying power both inside and outside the bracket, the law says we multiply the two. So you see minus 1 is multiplying s, that becomes 3 raised to power minus s is equal to, what to open this bracket also with the help of this same law, 3 times s will be 3x, 3s minus 3 times 4, that is 12. You see, when the bases are equal, we have the impetus to equate the powers. The base here is 8, and in this case, we are having the base of 3 and 3 both on the left hand side and on the right hand side. So if I write minus s equal to 3s minus 12, we are very correct. You see, so I want to bring the term that contains s together. This 1 minus s minus 3s equals to minus 12. Yeah. So minus s minus 3s is minus 4s equals to minus 12. If we divide by minus 4 on both sides, minus we cancel, minus 4 we cancel, 4. To be left with s equals to minus cancel minus 4 into 4, 1, 4 into 12, we have 3. Eventually our s is equal to 3. So we want to check if the s we have satisfy the equation because we have employed the usefulness of the laws. So if we do this, we have 3 raised to power minus 1 raised to power 3, s is therefore 3, equals to 3 raised to power 3 s minus 4. If you remember this, yeah. Okay, s is now 3, this is 3. And 3 raised to power minus 3 equals to 3 raised to power 3 times, okay, the bracket 3 minus 4 is minus 1, 3 raised to power minus 1. You see? So yes, 3 raised to power minus 3 equals to 3 raised to power 3 times minus 1. So if we employ this, 2 powers multiplying 3 times minus 1 to be minus 3. You see that? So the law that we have employed has been able to help us to evaluate our original equation, and we've got s to be 3. So when we check what was on the left hand side is exactly equal to what is on the right hand side, and this is our answer. Thank you for staying tuned. So if you are meeting us the first time, click on the subscription button, click on the notification button, because we have more videos are coming on this channel. Like also so that more person can learn from this skill that we are displaying. Thank you. Bye bye.